Let's go with lesson 18. Got a question there, have a go in your own time. I'm going to use the technique of look the same. Oh, by the way, the answer is x equals -1 in case you're wondering. Look the same. I need to make this look the same. I've got one item with an x stuck in it. That says not likely I can do much with that. Can I make this look the same? I want this to look like 5 with a number above it. Oh, 5 squared. Got it. Which means by inspection those two objects must be the same. So x plus 3 is equal to 2. So I'm going to minus 3 from both sides, which gives me x equals -1. Ta-da! Done it. Next question. Have a go in your own time. Answer is x equals 1. Oh, we got two objects multiplied together that equals 0, which must mean that one of them is equal to 0. So either x equals 1 or x equals 1. Wait, I didn't mean that at all. Either x minus 1 equals 0 or x minus 1 equals 0. X can't be two things at once, so that's why it's an or. So if we add 1 to both sides, that's x equals 1. Add 1 to both. Oh, wait, it's exactly the same thing. Oh, so we just need one of them. By the way, you may have said brackets repeated root. Just commenting on this because you may have said that. If so, congratulations, you've learned that somewhere else. But we're not worrying about that here. Because we're trying to remember, these 20 lessons are focusing on certain skills. Have a go at this one in your own time. What do we do with this? What does the squared mean? Oh, the squared just means that you multiplied two. Oh, it's exactly the same question as before. Oh, right, so blah. I'm not even going to bother with that one. I'll just do this. X minus 1 equals 0. Add 1 to both sides. X equals 1. Bam. Next question. Have a go at this in your own time. There's a 5. What does that mean? Oh, that just means I have to write it out 5 to... Oh, I can see it. Oh, this is what's happening. I'll just do it anyway so we can see it. Oh, look, it's that, which means one of these 5 things has to be equal to 0. And they're all exactly the same, so let's just not bother with those. The same. Add 1 to both sides. X equals 1. Ta-da. Next question. Have a go in your own time. And the answer is x equals 0, or x equals -2, or x equals -3. I'll show you how I did it. There's 3 different objects. There's an x squared, and an x cubed. This cannot be solved because there's 3 variables and only 1 equation. This is impossible. Oh wait, but maybe I can use the trick. Let's see if the trick works. Which means I have to try and factorize. And the first thing I do when I try and factorize is I try and take something out. Is there something I take out? Yes, there is. I can take out the x. X squared plus 5x plus 6. Okay. Is there something else I can take out? I should try again. No, there isn't. What's the second thing we do? We try and make double brackets. Let's do that next. X, I shouldn't be writing that yet. Double brackets equals 0. Can I make this? Yes, because we recognize this. We've done this a million times. I'm using the same thing, like I said before. So just trying to focus on learning certain core skills in this series of lessons. Oh, so x equals 0, or x plus 2 equals 0, or x plus 3 equals 0. Let's just, so -2 from both sides here, that means that x equals -2. -3 from both sides here, that means that x equals -3. Bam, sorted. Next. That's supposed to be a 0. That's supposed to be a 0. That's supposed to be a 0. Okay. And how do we do this? Well, the answer is q equals -1 over 100, or q equals -1. And let's have a look at this. There's two different variables. There's two different unknowns. So we can't solve it because there's only one equation. Oh wait, I wonder if we can use the trick, which means we have to factorize. They don't share anything in common. Let's try double brackets. Right, immediately I can see it's got to be +1 on each side, assuming this works. Because it might not be possible, although we know it's possible because I just told you the answer. But we don't pretend we don't know. So if it works, it has to be +1, +1. And we know that we can't split up the q, so we've got to put 1q on each side. How do we make 100q? We could do 1 times 100. Oh, that's obviously going to work because look, there's 101 here. So that makes sense. So let's put 100 there and then 1 there. We don't need to write a 1. That was unnecessary. We've now got two things multiplied together. So one of the two things must be equal. That was really bad there. I shouldn't have crossed out my working, so I'll just leave that there. I'll maybe just put a box around it to keep it out of the way. 100q plus 1 equals 0, or q plus 1 equals 0. I'm going to minus 1 from both sides here. 100q equals minus 1, and then I'm going to divide by 100, which means that q equals minus 1 over 100. There you go, so that was the first answer. Minus 1 from both sides here. Q equals minus 1. Bam, sorted. Next question. Have a go at this in your own time. And the answer is a equals 0 and or, this is an and or because we've got three different objects, and or b equals 0 and or c equals 0. Because three things multiplied together, at least one of them must be 0, possibly more. Have a go in your own time. Not possible. Why? Because we have an A, we have a B. So far so good because there's two equations. But bad news, there's also a C. There's three unknowns, there's only two equations. We can't do it. Let's do the next question. Write as one fraction. My questionable capitalization in titles continues. For some reason this time I've only capitalized the first word. Have a go in your own time. I'm just writing out the answer and then I'm going to actually do it as usual because that means you can skip, blah blah blah. You know the score by now. So okay, it's 1/8, 1 plus 1/b plus 1c. I can't combine those, they're three different objects. So I guess I need to make them the same. I guess so you've got to be creative here, and then you kind of realize, oh well, if I multiply that by b and that by b, that by b and that by b, that solves the b problem. Then if I multiply this by c, let's use a different color. I think I'll make it clear. Then I multiply this by c and this by c. That deals with the c issue. It's now just the a issue remaining. So I'm going to multiply that by a, that by a, that by a, that by a. I'm just going to put circles around just to make it clearer which one's associated with this one. Let's do it. So we've now got CB over ABC minus AC over ABC plus AB over ABC, which is CB minus AC plus AB divided by ABC. I'm going to critique my own working here. I've made what I would consider a mistake, and I would point this out to a student. That's not very good. Should be BC. Always try and write things in alphabetical order. The reason you do that, someone taught me this once, is it means if you just get into the habit, it means that if you've got, say you're doing some really complicated working, and you've got stuff over here, 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 you might write BC here and then CB here, and you might not notice they were the same thing. But if you write them the same way round, it's much easier to notice. Oh, it's the same thing. So that's why you do it. So you get into the habit of writing them in alphabetical order all the time. It's the very occasional exception to that, like if it's playing around with consonants and that kind of stuff. But basically, that's the general kind of rule. Make L the, what's the next word going to be? Subject. Have a go in your own time. There's going to be a bonus lesson on this. Is there? No. No, there isn't. Oh, well, there kind of is. There's a bonus lesson on something related to this. So, right, now the answer will eventually be L equals the square root of 3qm. So let's see how we get to that. Make L the subject. Make L the subject. So I've just got to start shifting things away. I like to occasionally mention this tip. One of the things I like to imagine this is written on a piece of paper that I've just circled in blue, and you shake the piece of paper. What's going to fall off first? I think the M is going to fall off first because that's kind of loosest. It's least connected to the L. Anyway, that's just a way I think about it. So I'm going to times both sides by M because that will make the M on the left-hand side cancel. Ta-da! That cancels. Let's write that as MQ because it's in alphabetical order. What's going to fall off next time I shake it? Well, clearly the 3 is quite loose because the squared is really strongly connected to the L. So now I'm going to divide by 3. I'll do that over here. So that gives me L squared equals MQ over 3, which immediately tells me this answer was wrong. So you might have been watching this thinking, oh, I'm looking forward to finding out how Duncan did that. Well, it turns out I did it wrong. What are we going to do next? We need L on its own. So the 2 is the last thing we need to get rid of. What's the opposite of squared? The opposite of squared is square root. So I'm going to square root both sides. And then the square root and the squared cancel, which gives me L equals the square root of MQ over 3. Ta-da! Next question. Let's do some calculates. Yeah, the bonus lesson, you might have just been a bit confused by the whole square root. You're like, wait, when you do the opposite to both sides, you're now doing square roots as well. What's going on? In which case, there's a little bit of an explanation. And also doing the same thing to both sides is, it's awkward. There are some advanced issues, which we haven't bothered touching on, and they're not vital, they don't really matter, but you might be thinking about them, in which case feel free to watch the bonus lesson, just to pick up some kind of tips about some of that. There are some variations on a theme here. Have a go in your own time. And the answers are 6, 0, 0, minus 6, minus 6. Remember, it doesn't matter what's coming before. If you then times it by 0, it's just going to be 0. The 1's irrelevant, which is why minus these last two are the same, because the times 1 doesn't change anything. Also, notice the brackets don't really make any difference in this case, because nothing then is happening particularly special afterwards. Let's do the next question. It's another calculate. This time there's 3 of them, so I'm going to write them out. Have a go in your own time. And the answers are jump to the next question if you're happy. Otherwise, let's look at some explanations. Remember, minus means flip, so I'm going to do that straight away. That gives me 49 over 25. But the indices, the power is like a recipe. We have to do all the instructions. We've only done one of the instructions so far. We still have to do the half. Oh, that just means square root. And I just from experience, I know that I can just square root the top and square root the bottom separately, which is 7 over 5. What does 4 mean? It just means you have to times it by itself 4 times. And you end up with 1 over 60. Because remember, when you times a fraction, you just times the bottoms, and you on the tops you just keep timesing 1 by 1, 1 times 1, 1 times 1, so you still get stuck with 1. Here, the 1 is irrelevant. The minus means flip, so when we flip it, we end up with 5 over 1, which is just 5. Next question. This is a functions question. And again, I'm not really writing much for question. That's supposed to be f of 10, by the way. Have a go in your own time. There's 4 clues for this one. You might have unpaused, you might not have been able to do it. There's 4 clues, 4 whole clues, and they're all relevant because they've all got an F. So maybe that's because it's a slightly more complicated question. So maybe have another go. Anyway, the answer is this. How do I work that out? Because, well, I kind of feel like it's a pretty good clue straight away. How do you get from 10 to 21? That's kind of doubling it, adding 1. Oh, this one looks helpful. That's definitely times 2 plus 1. Oh yeah, and 0 times 2 is 0. And then if you add 1, you get, yeah, and it works. Yeah, got it, sorted. And then minus 10 times 2 is minus 20. Add 1, you get minus 19. Let's do a factorize. Have a go in your own time. Welcome back. Did you put not possible? Because remember, we're allowed to put not possible. Because that's the thing. This actually is possible. It is possible. Pause the video and try again, maybe. Okay, did you just unpause for the second time? You're like, I still can't do it. Then my final clue is, remember the process. The first thing is we try and find something that's in common. If that isn't the case, then we try and do double brackets. And I'm telling you, this is definitely possible to factorize. So one of these two is going to work. I promise. Okay, go away and try again if you couldn't do it. And, okay, well, you clearly, number 1 doesn't work. So it's going to have to be number 2. So we're just going to write double brackets and see what happens. How do we make x squared? Well, it's clearly x times x. Okay. Well, then how do we make minus 9? 1 times 9, 3 times 3, 3 times... I'm going to go with something symmetrical because that kind of feels right. And how do we make a minus? It has to be a minus and a plus. Let's test it. X times x is x squared plus 3x minus 3x minus 9. Let's add those together and check. X squared. Oh, they cancel. Minus 9. Ta-da! So let's just write the answer out neatly again. The answer was x minus 3, x plus 3. That was the answer. Did you see how we did it? I like to think that's quite a nice example of how powerful this is. This technique of having a 2-step process for factorizing. Let's do some more calculates. I'll let you know when I've written the whole list. Have a go in your own time. 3, 1, 0, not possible, not possible, because you can't square root a negative number. Because the reason that square root of 9 is 3 is because you need something times something makes 9. It has to be the same object. Obviously 3 times 3 makes 9. And what times what makes a minus? What times what makes minus 1? Could it be minus 1? No, it doesn't work because minus 1 times minus 1 is plus 1. Yeah, so it doesn't work. By the way, again, just to briefly mention, there kind of is an answer for these, but we're just not going to worry about that now. That's not really within the syllabus of these lessons. And we're going to do a plot question. No, we're not going to do a sketch question because we're lazy. What do we have to do when we do a sketch? So there is a minimum. Can you remember? See if you can make sure you get all the points in a sketch question. What are the minimum things we have to do? And we need to draw the axes, we need to draw the arrows because you have to show which direction is positive without the arrows telling which is positive. We have to write a 0 because you have to show that, oh yeah, that center point, that means 0. Now let's draw the graph. I'm just going to draw it straight away, then we'll talk about it. That's a minus 3. Do you know what? We've gone over this so many times. Obviously, blah, 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 plot some points until you've worked out what it is, blah, 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 blah. Oh yeah, I know what it looks like. Anyway, here's another way of thinking about it. Let's get rid of that. Another way to think about it is, ooh, it's like x squared. That's like y equals x squared. But it's just decreasing. The y value is 3 less each time. So it's y equals x squared minus 3. So it's minus 3. So it's decreased by 3. So the whole thing is lowered by 3. Last question. Simplify if possible. As a list, I'll let you know when I've finished. The one I've just written out there, that might be too difficult. If it is, don't worry. I'll just show you, and then, I mean, you'll have seen it, but remember, learning is a process where you can just kind of see things, and you don't have to learn everything straight away, but just being exposed to it can help. Right, I'm going to write out the answers. This is obviously, I'm assuming you've already paused it and had a go. So I'm going to write out the answers. This is the last question, so as soon as you're happy, you can just kind of leave the video, and I'll see you in the next one. I'm going to talk about these answers for a bit. This first one, this bit here is x, this bit here is x, x times x is x squared. Bingo. The next one, we've just got 4 objects added together. There's 4 of them, so it's 4 root x. Like elephant plus elephant plus elephant plus elephant is 4 elephants. I'm going to save this one till last. This one here, I'm going to put a plus in front of that. Oh look, so I can cancel out that plus and minus, which leaves us with minus 2 root x. So that explains that one, because there's 2 objects there. Let's just do this one here. Remember, how are we going to do this? Remember I said that when you're dividing, you're just making something smaller. So if you divide something that's already got a divide, the divide just kind of sits in the same place. So what we've got is you've got root x divided by root x. So that's dealt with that one. I'm going to use a different color. Use different color. Right. We've got root x divided by root x. That deals with the first 2. Where do we put the next root x? The answer is that just goes on the bottom, as we've discussed at least a couple of times now, I think, which is that it's just making it smaller, so it has to go on the bottom of the fraction. The next one also goes on the bottom of the fraction, it's just making it smaller. Oh, look, we can cancel those. What happens when you cancel in a fraction? Well, 5 minus 5 is 0. 5 divided by 5 is 1. So when you're cancelling in divide, you have to make sure you leave a 1 behind. What's the square root of x times the square root of x? It's x. So it's 1 over x. Ta-da! See you in the next video.